To fix this, we have to take the absolute value of the output from our fast Fourier conversion, and we also have to clamp the maximum values to be the maximum value that can be displayed on an image. Now looking at our image, there is one more defect that we can see, or artifact that we can see, and this is relevant to ideal filters or ramp type filters, the same thing that we had in one-dimensional audio filters, and that is a wavy like artifact that can be represented as unwanted noise. In order to remove that, we should, instead of using an ideal low pass filter, we should in fact use a Gaussian low pass filter. In order to do that, let's define a function for a Gaussian filter. And the Gaussian filter, just like with one-dimensional frequency domain, also needs to have its maximum values at 1 instead of the area being 1. And then we just apply the Gaussian function into the distance calculation and use that to generate our filter. And this will generate a very nice, smoothly blurred image. To convert this filter into a bandpass filter, for instance, instead of a low-pass filter, we can just manipulate the values generated by the distance calculation so that when they go into the Gaussian calculation, they would generate a halo around the image center instead of being focused in the center. The benefit of applying it to the distance calculation is that we can just easily swap out the type of filter instead of manipulating the filter function directly. So the same thing with an ideal filter.